Chapter 3 Volume and Nets. Volume. We have already learned how to measure line segments and plane regions. Now we will learn to measure solids such as a cuboid or a cube. Every solid body occupies a certain space which is called its volume. We measure volume by using a unit solid. The unit solid is a cube of side 1 millimeter or 1 centimeter or 1 meter. The number of such unit solids or unit cubes contained in the given solid gives the volume of the solid. The adjoining figure represents a unit solid or a unit cube of side 1 centimeter. Remember, 1. We measure a line segment by a unit line segment, centimeter or meter, and see how many such line segments are contained in the given line segment. 2. A region area is measured in terms of a unit region, square centimeter or square meter, and see how many such unit regions together make the given region. 3. A space volume occupied by a solid can be measured in terms of unit cube of side as 1 millimeter or 1 centimeter, etc. The unit cube of 1 centimeter means 1 centimeter each in length, breadth, and height. The volume of this unit cube is written as cubic centimeter, or centimeter cube. Finding volume by counting cubes. We count the number of unit cubes contained by the solid, which give us the space occupied by a solid. The total number of unit cubes gives us the volume of the solid. Example, find the volume of the cuboids given below. Solution, we divide the given cuboids into unit cubes as shown below. We see that the solid A can be filled completely with 48 1 centimeter cubes. Thus, the volume of solid A is 48 cubic centimeter. Similarly, solid B can be filled with 16 1 centimeter cubes. Thus, the volume of solid B is 16 cubic centimeter. Determining volume by calculation. Observe the figure of a cuboid given alongside. It is 5 cm long, 4 cm broad, and 3 cm high. There are 61 cm cubes in all, so the volume of the cuboid is 60 cubic centimeter. Thus, volume is equal to 60 cubic centimeter is equal to 5 cm into 4 cm into 3 cm is equal to length into breadth into height. Therefore, volume of a cuboid is equal to length into breadth into height. Look at the figure given alongside. It is the figure of a cube whose length, breadth, and height is 2 cm each. There are 8 1 centimeter cubes in all, so the volume of the cube is 8 cubic centimeter. Thus, volume is equal to 8 cubic centimeter is equal to 2 centimeter into 2 centimeter into 2 centimeter is equal to side into side into side. Therefore, volume of a cube is equal to side into side into side. Example, the length, breadth, and height of a cuboid are 12 cm, 8 cm, and 6 cm respectively. Find its volume. Solution, length of the cuboid is equal to 12 cm, breadth is equal to 8 cm, height is equal to 6 cm. Now volume of the cuboid is equal to length. Now volume of the cuboid is equal to length into breadth into height is equal to 12 cm into 8 cm into 6 cm is equal to 12 into 8 into 6 is equal to 576 cubic centimeter. Example, find the volume of a cube whose edge is 12 centimeter. Solution, find the volume of a cube whose edge, I repeat, find the volume of a cube whose edge is 12 centimeter. Solution, length of an edge of the cube is equal to 12 centimeter. Now volume of the cube is equal to edge into edge into edge is equal to 12 centimeter into 12 centimeter into 12 centimeter is equal to 1728 cubic centimeter. Example, a tank is 1 meter long, 70 centimeter wide, and 40 centimeter high. How many cubic centimeters of water will it hold? Solution, length of the tank is equal to 1 meter is equal to 100 centimeter. Breadth of the tank is equal to 70 centimeter. Height of the tank is equal to 40 centimeter. Now volume of the tank is equal to length into breadth into height is equal to 100 centimeter into 70 centimeter into 40 centimeter is equal to 280,000 cubic centimeter. Thus, The tank holds 280,000 cubic centimeter of water. Remember, before finding the volume, convert the length, breadth and height into the same unit. Using a shortcut, look at the cuboid shown alongside. The volume of this cuboid is equal to the total number of cubes in it. Each small cube measures 1 cubic centimeter. Number of cubes in one layer is equal to 7 into 3. Number of cubes in 4 layers is equal to 7 into 3 into 4 is equal to 84. Volume of the cuboid is equal to 84 cubic centimeter. Volume of a cuboid is equal to number of cubes in a layer into number of layers is equal to length into breadth into height. V is equal to L into B into H. Example, find the volume of a cuboid of length 5 cm, breadth 2 cm and height 4 cm. Solution, V is equal to L into B into H is equal to 5 into 2 into 4 is equal to 40 cubic centimeter. The volume of the cuboid is 40 cubic centimeter. Example, find the volume of a box with each side measuring 8 centimeter. Solution, V is equal to L into B into H is equal to 8 into 8 into 8 is equal to 512 cubic centimeter. Hence, the volume of the box is 512 cubic centimeter. Example, find the length of a box of volume 100 cubic centimeter with height 5 centimeter and breadth 4 centimeter. Solution, V is equal to L into B into H. Therefore, L is equal to V divided by B into H is equal to 100 divided by 5 into 4 is equal to 100 divided by 20 is equal to 5 centimeter. The length of the box is 5 centimeter. Nets, two-dimensional shapes, triangle, square, rectangle, circle. These shapes have only length and breadth, that is 2 dimensions. These are two-dimensional shapes. Three-dimensional shapes, cube, cuboid. These shapes have length, breadth and height, that is 3 dimensions. Converting a 3D shape into a 2D shape, take an empty pencil box, open it. How many faces does it have? How many faces does it have? Does the open box have the same number of faces as the closed box? Yes or no? Converting a 2D shape into a 3D shape. Take an A4 sheet of paper. On it, draw the shape shown below. Paste it on cardboard. Cut along the solid lines. Fold along the dotted lines. Join the corners with tape. You have changed a dash dimensional shape to a dash dimensional shape. A plain 2-dimensional shape used to make a 3-dimensional shape is called a net. Nets are used to make layout plans of houses, buildings, bridges, and so on. Net of solid figure. Net is 2-dimensional 2D tool for representing 3-dimensional 3D object. Let us do some activities to convert a solid 3D figure into a 2-dimensional figure 2D. Net of cube or cuboid. A. Let us think of a cube and look at the following figures carefully. B. Let us think of a cardboard box of cube-shaped, a 3D figure, and generate the 2D figure by cutting and flattening its edges as shown in the following figures. When the figure 3 is viewed from top, it looks like the figure 4 as shown. The figure 4 is usually called the net of the cube. By splitting this cube-shaped box in different manners, we can generate some more different nets. Remember, 1. A net of a cube always has 6 squares. Each square corresponds to each face of a cube. 2. There can be 1 possible nets of a cube. 3. The nets of a cuboid are similar to that of cube. It has 6 rectangles. Net of cylinder. We can extend the technique of getting nets of cube in generating the net of cylinder. In our day-to-day life, we come across several solids like circular pipe, measuring jar, gas cylinder, etc. These solids have cylindrical shape. Let us think of any cylindrical shaped object, say a small pipe. Wrap up a paper such that it completely covers the pipe. Now, the shape of the paper which completely covers the cylinder is the net of the cylindrical shaped pipe. Now cover its top portion of pipe by making a suitable circle-shaped paper and spread it. Now close the both ends of pipe and spread it. Net of cone. There are various objects in our everyday life like the tapered end of a pencil, ice cream cone, a conical vessel, etc. The shapes of these objects are conical. We call them cone-shaped. Let us take a cone-shaped object and wrap paper around it such that it completely covers the cone. Now spread the paper. Open. Net of a cone which has open base. Now think of a cone closed from the bottom. The circular part in this net can lie anywhere in arc AB. We have seen how the net of a 3D object is generated. In the similar way, if net of an object is provided, we can generate the corresponding three-dimensional object. Example: which of the following objects represents the net given below? A. Measuring jar. B. Football ball. I repeat, football. C. Shuttle used in badminton game. D. Book. Solution: A. Measuring jar is a cylindrical shaped object closed at the bottom end. Since there is no side provided at the top portion of net, the given net represents the measuring jar. Corresponds to cylindrical portion of the jar. Corresponds to closed bottom circular portion of the jar. Example: match the each net provided in column A to its corresponding object provided in column B. Tapered end of the pencil is conical in shape. Die is a cube-shaped object and pipe is a cylindrical object opened from both ends. Example: generate the net of the following object which is opened from the bottom. Solution: the given object is a combination of two 3D figures, that is, a cylinder opened from both ends and a cone opened from its base. Therefore, one of its possible net will be as follows: cone, cylinder, open. Net of conical portion, net of cylindrical portion. Net of the object.